7.1 is a section on measurement. The first thing we're going to learn is the U.S. customary units of measure, then we're going to learn the metric system, and then we're going to learn conversions between the U.S. customary units and the metric units. So there's a few sections in this chapter in this entire class that I'm very, very passionate about. One of them was 11.0, which is how big is big, which is about the size of our debt and what's going on in realistic, okay? So the next section that I'm really passionate about for sure is measurement. And why this just gets my blood boiling is because what the U.S. uses versus the rest of the world. So what does the U.S. use? The U.S. uses the U.S. customary units of measure. And so for what do we have? We have length, we use inches, feet, yards, and miles. For weight, we use ounces with OZ, pounds, LB, tons is another one. And then for capacity, for space, fluids, a lot of people think of that. We have fluid ounces, which are not even close to the same thing as, well, they're close to the same thing, but not the same thing. This is capacity, size of something. And then there's ounces, which is weight of something. So obviously the size of something is not necessarily, in fact, almost definitely not the same as the weight of the thing. So we have fluid ounces, cups, pints, quarts, gallons. Absolutely ridiculous. The numbers that you see here, 4s, 2s, 8s, 2,000, 16 to 1, 5280, 3 to 1, 12 to 1, all of these are horrible, horrible, horrible numbers. So what I spend a large time of talking about in class is where do these numbers come from? Where did we get these numbers? And once you find that out, you realize how ridiculous the U.S. system is, why we should never be using the U.S. customary units of measurement. Right? The U.S. is the best country in the world to live. I agree. It's the best country in the world. No, it's not. Maybe to live, but certainly not the best when it comes to measurement. In fact, we are one of only 3 or 4 countries in the world, and I guarantee you if you don't look it up, you probably couldn't find what those other 2 or 3 countries are. I know one's a tiny one in Africa, West Africa somewhere. But tiny, tiny little countries with no name, no big economy. We are one of 3 or 4 countries in the world that uses this system. The rest of the hundreds of countries in the world all use the metric system. Every single other country, except for like 3, realized this is not the way to go. This is the worst measurement system ever. Okay? Where does it come from? Well, the first thing we have is an equivalence. We started off with the first measurement of an inch. So what is an inch? An inch was measured by an old king. This old pompous, arrogant guy said, we are going to use my body to measure. So what was an inch? The inch was the tip of his thumb, from his tip to his first knuckle. That is the measurement that we use today. That's where an inch came from. A foot, yes, indeed, that was this king's foot. You are talking about using an old dead guy's foot as our foot. What was a yard? A yard was a march, which would be a left foot, right foot, where you do a left step and a right step. That was a yard. And then what was a mile? A mile was when you did, a yard was one step. A yard was one step. And then a mile was when a army, battalion, or whatever did 1,000 marches. So left foot, right foot, stop. Left foot, right foot, stop. Left foot, right foot, stop. So they did that 1,000 steps, and that created a mile. So we're using an old dead guy for an inch, an old dead guy for a mile, or for a foot, one of his steps for a feet, and an old army marching regiment for how long a mile is. This isn't BS. Google it, look it up. Blew my mind when I figured this out. It has nothing to do with anything important. These numbers are absolutely horrible. And yes, because it is our U.S. system, you are responsible for memorizing these. So you need to memorize every single one of these. Well, that's not really true. You need to memorize all the lengths. So you need to know there's 12 inches in a foot. There's 3 feet in a yard, and there's 5,280 feet in 1 mile. Okay? Next thing you need to know is you need to know our weight. Our weight, when they say how much do you weigh, you would tell me how much you weigh in pounds most likely. Okay, if you use the U.S. system, you would. If you think about other weights, for instance, what's the weight of a baby? They might say something like 7 pounds, 4 ounces. So what is it? There's 16 ounces in a pound. Some of you might know ounces from something else that we probably shouldn't mention in class, so we won't go there. And then the last one that we have to know for weight is a ton. Okay, and this isn't a metric ton, this is a US ton, that's 2,000 pounds, which is different than a metric ton. Don't worry, it gets even more confusing. So all we have is 16 ounces to a pound and 2,000 pounds to a ton. I do expect you to know that as well. So the last ones, what I would do without a doubt, because I am allowing you a note card on the test, I would put these ones on the note card. I think those first ones, of course, you could put on your note card, but this one for sure would be on my note card because there's no way that I could memorize this. What's the idea? There's 8 ounces to a cup, there's 2 cups to a pint, 2 pints to a quart, and 4 quarts to a gallon. So here's a nice little graphic that I found that someone showed me at one point in time. If you look at this, the whole thing is a gallon. So how many quarts are there? There's 4 Qs in a gallon. And then each Q has 2 pints because 2 pints make a quart. And then each P has 2 Cs because 2 cups make a pint. So if you look, there would be 4 cups to a quart. There's 4 quarts to a gallon. There's what? 8 pints to a gallon? Okay. So if you look at this picture, you can see exactly what it is for conversions between all of them. All right. So it says these equivalencies can be used to change from one unit to another unit by using the conversion rate. And we've already done this in some of our other sections potentially, but we're really going to hammer it down now. How do we do conversions? It says because 12 feet is equal to 1 inches, we can write 2 conversion rates, 12 inches over 1 foot and 1 foot over 12 inches. So let me motivate this. Here's how I motivate this problem in class. When I'm in class, what I do is I hold up my marker. So I'm not a good artist. Remember, I'm a mathematician. So let's say here's my marker right here, okay? So there's my marker. And what I do is I say, how long is my marker? And I literally hold my marker that's in my hand that I've been writing with up in the air. And I say, how long is it? And then I get out a yardstick and I measure how long this marker is, okay? And when I look at it, this marker, it's not exact. It's like 5 7/8 of an inch, or even worse than that. I think it's like 5 and like maybe 9/16. I can't even remember. It was a horrible length. But what I did was I said approximately, let's say this is approximately 6 inches. The marker is approximately 6 inches. And so everyone looks at that, and when they were guessing, I asked them to guess how long it is. Everyone told me inches. No one told me a measurement in anything but the unit inches. So what I asked is if I assume the marker is 6 inches, if the marker is 6 inches, I want to know what is it in feet. And I have a lot of people say, oh, well, it's half a foot. And they know that instantly, and they're, oh, great, I know. And I said, okay, why? Why is the marker half of a foot? And so then we start talking, and we sit there and we start off with the number 6 inches. Now, I cannot change the length of that marker. That marker is 6 inches long, and if I want to measure it in feet, I'm going to have a different number for feet, but I cannot change the size of that marker. It's still equivalent to 6 inches. So the length 6 inches in terms of feet is what? And here's the ideal. What can I do mathematically to a number without changing it? What operations can I do to a number without changing it? So for instance, I could add or subtract 0 to a number and it still doesn't change it, right? Likewise, I could multiply or divide any number by 1 and I have not mathematically changed its size. So if I took 6 inches and I multiply it times the number 1, that doesn't affect it at all. It's still 6 inches, you agree? But what happens if instead of multiplying it by 1, I wanted to multiply it by the number 5 over 5, 5/5? Well, 5/5 is the number 1, right? So 6 times 5/5 is still 6. I haven't changed the size of it. Anytime I multiply it times the number 1, it's still the same. I haven't changed the size of it at all. So now I get a little bit deeper and I say, why is the number 5 over 5 1? Well, it's the same amount on top and bottom. Awesome, that's what I wanted to hear. So the same amount on top and bottom. So if that's the case, if it's about the same amount being on top and bottom, do you agree that 12 inches is the same amount as 1 foot? And they say, well, yeah, those are equivalent. So isn't the number 1 foot over 12 inches really the number 1 because it's the same on top and bottom? And they go, yeah. And I said, okay. So if we multiply something by 1 foot over 12 inches, we've really multiplied it by the number 1, so we haven't mathematically changed it at all. And they go, yes. And I say, okay, well, look what happens. Here, my inches, my units of inches cancel, and I'm left with, or simplify, I guess I should say, I'm left with 6 times 1 on top, and you divide it by 12. Anything across the top, you multiply. Anything across the bottom, you multiply. But now my unit's in terms of feet. So this is really 6/12 of a foot, which is the 1/2 foot, or you could have said 0.5 feet. I don't care. But that's how you get 6 inches is half a foot. The trick is multiplying by that conversion factor, the 1 foot over 12 inches. That's our conversion factor. All we have done mathematically is multiplied by the number 1. So we haven't physically changed the size of the marker. We have just multiplied it by the number 1. All we have changed is the units, not the size, just the units. I want you to pay attention to how I chose that. I did write 1 foot over 12 inches. Technically, I could have put 12 inches on top and 1 foot on bottom. But why didn't I put 12 inches on top? Why did I make sure 12 inches stayed on the bottom? Well, that's because I needed my units to cancel. I need my inches to cancel so I could be in terms of feet. I needed the inches to cancel, so that dictated which one of the 2 conversion factors I used. Both of those are conversion factors, 12 inches over 1 foot, and 1 foot over 12 inches, but I used the 1 foot over 12 inches so my units could cancel. So what's the idea? We're always going to start with what we're given. We're going to use this conversion ladder right here, and we're going to multiply it times a conversion factor. That conversion factor just means the number 1, and it's only used to change the units that we're doing.